So far we learned that we can find the slope of the lines joining the 2 points which are at an infinitesimally small distance. So we can get the slope of the this curve by finding the tangents slope. So what if we could plot the slopes at every x coordinate at every time interval, and in this case of the plane, in the plane's case, what if we could plot the slope of the line, or the slope in this case is the acceleration of the plane at every instant, at every times instant. So this is the time. The x axis remains the same, but the y axis represents something different. It represents the slope of the line. By the line I mean this line right here, the line of the trajectory of the plane, the velocity of the plane, the velocity line, the speed line of the plane. I'll say speed because there is no there is no direction mentioned here. So what if we could plot the slope of the line right here, or the acceleration of the plane at every time instant? So this is a very nice tool given to us by calculus. This tool is called differentiation. So here we saw that the slope of a straight line will be delta y divided by delta x. But we saw that we could take the where the delta y the y is changing, the 2 points. In this case, in a straight line's case, the delta y is taken for the 2 points which are at the end of this line. But what if we could take the points which are at an infinitesimally small distance? So this distance will become delta y will tend to 0. So there is a we can denote it using dy, and the delta x will also tend to 0, so we can denote it using dx. So if so this will become the slope of the point of the curved line. So the slope of the tangent, actually the slope of the tangent which is associated with the curve at every point. So this will be the slope. We can also denote it if somehow we find the function of the trajectory of the plane from, say, the trajectory of a plane is a quadratic equation. Say the plane is taking off and then landing, so this looks like some quadratic equation. We say this as y equals to some function, so that is, the function is denoted by f of x. So the slope of this function, the graph of the slope of this function will be f dash of x. Don't get confused in dy by dx or f dash of x, because they are both one and the same. So the plotting of the slope at every instance in time will be called the differentiation of this function, the differentiation of the path of the plane. So how can we differentiate it? Let's get to the to another page. So we have a function x square, and its graph will look somewhat like this. At x equal to 1, the y value will be x squared, which will be 1. At x equal to 2, it will be 4. At x equal to 3, it will be 9, and so on. So this function is f of x is x squared, or y is x squared. So if we want the slope of at every point in this graph, the slope at this point, the slope at this point, the slope at this point, then we should graph it using x. What is the x value here? The x value here, and the slope of the line at x. So if this function has a pattern right here, then this function should also have a pattern. This is changing, so the slope here was a little less, the slope here was increasing, the slope here was increasing, and the slope may be at x equal to 10 raised to 10 would be somewhat infinite. It will tend to infinity, it will not be infinity, but the slope of the curve, when the x value will get too large, say it will get 10 raised to 10, which is according to me a very large number. So the slope of the curve will get to tend to infinity, so it is also having a pattern. So if we plot this, so what will be the function of the graph, what will be the function of the graph of this graph right here, which denotes the slope of the line at every x coordinate, at every x. So at 1, what is the slope of this graph, this line? At 2, what is the slope of this line, the tangent? So what is the function of this graph? The differentiation, the derivatives graph, we can call it the derivative. So what will be the f dash of x? This is also called the f dash of x, as we discussed earlier. This is called the f dash of x. So for x squared, we know that the graph at every point, the graph of the slope at every point will be 2x. So at x equal to 1, the graph will be 2, the slope will be 2. So this will be a linear graph. At x equal to 1, the y value will be 2. So we are indirectly saying that at x equal to 1, if we draw a tangent to the line, then the slope of this will be 2. At x equal to 2, if we draw a tangent to this line, the slope will be 4. At x equal to 3, if we draw a tangent to this line, the slope will be 6. So it will be twice the amount of x. This is the function of x squared. So there are formulae to this. There will be a formula sheet. So this is the formula sheet right here, and let's see the formulae one by one. I'll explain to you what these mean. So the dx by dx. So we have seen the differentiation formulae, which is dy by dx. This is not a division symbol, but it is differentiation symbol. It looks like division symbol, but it's not different division symbol. It's called the differentiation symbol. So here we can see that instead of y, they have written dx by dx. So this can be written as dx by dx. They have written it in a fancy way, like this, in a bracket, but it means the same. It's like this. So dx by dx. So they have changed y by x. So y is equal to x. So we can infer that the function is y is equal to x. So if y is equal to x, then it is a straight line, right? If y is equal to x, what will be the slope of the line? If y is equal to x, at x equal to 1, y value will be 1. At x equal to 2, y value will be 2. At x equal to 3, y value will be 3, and so on. So if the for every x value, what for every x value, what is the y value that is changing? So imagine you are climbing stairs, and for each stair, how many one stair is say 1 meter long, and for each 1 meter, how much is your height increasing? So say it is 2 meters. So the line this will denote will be y2 minus y1, that is 2, because it is increasing by 2, and x2 minus x1. So the y2 minus y1 divided by x2 minus x1. So in this stairs scenario, the denominator is 1, so the slope will be 2. So for every, if you can see, for every staircase that you are climbing, you are just going 1 meter away. So that is equal to the y2 minus y1 is equal to x2 minus x1. So both the things are equal. So when these are equal, the slope will be 1. That is what they are saying. The slope here is 1, which we can infer intuitively too. So also for d of say there is a function of f of x is 3x. So what will be the graph of this? This graph will be like this. It will also be a linear graph, but having a little more slope. So at x equal to 1, the y value will be 3. So it will be 3 times the x value. So if we say that this is a constant, this is what they are saying here. For each and every x, what is the height we are climbing? Look at the stairs scenario. So what is the height we are climbing here? It is 3. If this is a linear graph, the height at every point will be the same, the slope at every point will be the same. So it is 3 in this case. So what is the 3? Surprisingly, it is the also, if we, the coefficient of x. In this case, it is the coefficient of x. So we can generalize this by saying that if f of x is equal to ax, where a is some constant 3, 4, 5, 6 and so on, then the slope at every point, the slope at a given x point, we can say at given x point, will be a. In this case it is 3, because we took the function as 3x. So this is a. This is what they are saying. So if we take a graph of 4x, f of x equals to 4x, then tell me what is the derivative. We will use the word, we should get used to using the word derivative here. What is the derivative of d of 4x dx? So dy by dx, we are substituting y as 4x. So intuitively you should know that if we are substituting y as 4x here, then what will be the y value of the graph? Y equals to 4x. That is as simple as that. So we know as an trained people that d of ax by dx is always a. The derivative of ax is always a. So here 4x, so what will be the derivative of this? This will be 4. So the slope at every x coordinate will be 4. So let's move on. Here we have the third equation, d of x raised to n by dx. So we according to our logic, that dy by dx, so the y we have substituted by x raised to n. So what should be the function of the graph? You tell me now. You can pause the video and answer for yourself. So the function here will be y equal to x raised to n. Sorry, x raised to n. So what will be the derivative of this? As we saw earlier, when we draw the graph of x squared, y equals to x squared, what was the graph of the slope? It was 2x. What was the function of this graph, where it denoted the y-axis as the slope and the x-axis as the x-axis of this? So what was the function of this? What was the f dash of x when f of x was equal to x squared? So it came out to be 2x. So when remember this rule, when y equals to x raised to n, the f dash of x, you can write it as y equals to x raised to n, or you can write it as the function of x equals to x raised to n. So the f dash of x will be nx raised to n minus 1. So this will be the function of the slopes graph. So the graph here, the f dash of x will be nx raised to n minus 1, which we can see right here also. So when the f of x was x squared, the f dash of x came to be 2x, which is nx raised to n minus 1, which is 2 minus 1. So what is 2 minus 1? It is 1. So what is the f dash of x when f of x is x squared? It is 2x, which is written here. You can maybe take a screenshot of this. It will help you afterwards. Now when we saw the airplane sum, when I asked you what was the distance you traveled in the 3-hour interval, you answered me that you have to find the graph of the function. So if you want to find the graph of the function, we'll see integration sums afterwards. So these are all the formulae for finding the f dash of x, or the derivative, precisely saying the derivative of the function when the functions are the given here. So remember, many students do the mistake that they interchange these two functions. They say that cos x is minus sin x, and sometimes they say that minus sin x is minus cos x, and they just forget the minus sign, or sometimes they put an extra minus sign. So be careful for that. So I'll just explain you this one last. So if the function here, so if the function so if the function here is f of x is cos x, so cos theta also we can write. If this is f of theta, then we can write cos of theta, but in this case we'll take x, cos of x. X is just a variable we are taking. It's just for conventional letter that everyone takes, so we are taking. So how does the graph of cos x look? So it looks somewhat like this. So if we want it goes infinitely many times. So, and this is all the same. Yeah, so this looks somewhat like this. And if we want to find the slope at every point, so we have to draw the tangents. If this is the f of x, you just have to remember that what the f dash of x means. The f dash of x means the graph of the slope the graph of the slope with respect to the x. By the x we mean the x in this. So at every x, what is the slope at this point, what is the slope at this point, so it will denote the slope at every point. So in this case, as written here, it will be minus sine x. So here it will be, so the graph of the slope will be like somewhat like this. Yeah, somewhat like this. Because the graph of sin x, as you know, is like this, and it is written minus sin x. It goes like this, sorry. So it is minus sin x, so it will be flipped, it will be a reflection of itself along the x-axis. So the graph of the derivative, the f dash of x, the graph, if we graph the f dash of x, it will look like somewhat like this, uh, which we can infer by saying that at x equal to 0, when the function is cos x, at x equal to 0, what will be the slope of the line, the not the line, uh, the curve, the wave, what will be the slope of the wave at x equal to 0? So it will be, as you see here, it is the maxima. By this, the term, I'll explain to you what is the term maxima. So there are various terms, maxima and minima. So at maxima we mean where the slope of the graph becomes 0. It is the local maxima, where it is the maximum point, it has the maximum y coordinate in its locality, and also it is changing, so it has a slope of 0. So whenever there is a slope of 0, as you can see in this graph, this says the slope. So here the slope is 0, 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 and so on. So all of these are either maximas or minimas. So if we want to find it, if it is a maxima or a minima, means exactly what is it. So we have to dive into the term of double derivative, which we will discuss in the next video. So you can understand by this that the derivative of cos x is minus sin x, because this the if we could make a function of out of the slopes, the slope at every x coordinate of the cos x graph, then we get a function of sin x, sorry, minus sin x. That's the mistake many students make. Yeah. So here is the full length formula sheet that you may use. One more thing, the e raised to x is the strongest function. It is also known as the strongest function. You may have seen many memes on that, but it is the strongest function, because no matter how many ever times you derivate it or differentiate it, it stays e raised to x. So it has somewhat a graph. So if you make the f dash of x of it, it will be the same. The f dash of x will be e raised to x. In the next video, we'll discuss about the double derivative, the minima and the maxima. Thank you.